In this video, we will create a simple to-do list application. At the end of the tutorial, you will have learned how to display and modify C++ models in Qt. If you're not familiar with Qt or Qt Creator, we'd recommend watching the Getting Started with Qt Hello Quick World video first, as this video will assume some familiarity with these topics. The first step is to launch Qt Creator. We'll be using version 4.4.1 along with Qt 5.9.2. Let's create a new project. Click the New Project button. Select Qt Controls 2 application, and then click on the Choose button. Give the project a name. We'll call ours To-Do List, separated by hyphens. Select the suitable location for the project. We'll use the default location. Click Next when you're done. Next, choose a build system. We'll stick with the default, which is QMake. We're now given the option of selecting a Qt Controls 2 style. Choose Material from the combo box, and then click Next. Select the kit that you'd like to use, and then click Next. Click Finish to create the project. Our project has been created, and now we're looking at main.qml in the editor. Qt Creator generated some code for us that we don't need, so let's remove it. First, remove the code in main.qml, leaving only application window and its properties. Then, remove page1form.ui.qml by right-clicking on it in the project tree and selecting Remove File. Check the Delete File Permanently checkbox, and then click OK. We'll be doing most of our work in the editor, so we won't use ui.qml files. Next, rename page1.qml to todolist.qml by right-clicking on it in the project tree and selecting Rename. Add the following code to application window. Copy the imports at the top of main.qml and replace the imports in todolist.qml with them. Then, replace the top level item with a frame. The frame type comes from Qt Controls 2 and provides a convenient way to illustrate the boundary of our to-do list. Let's run the application. Click the Run button or press Ctrl R. We see a small, empty frame in the middle of the window. Close the application and return to Creator. Within the frame, add a list view. List view is the most common view type in Qt. There are three important things that list view needs in order to display data: a size, a model, and a delegate. The size determines the area within which the user can interact with the list items. Add the following code. Notice that we're using implicit width and implicit height instead of width and height. Implicit sizes are a natural or default size for an item. For example, the text type has an implicit size, which is the width and height of the text it contains. In our case, Frame will automatically resize itself to the implicit size of its child item, so long as there is only one item. We take advantage of that here so that we don't have to explicitly specify a size for the frame. The list view's model is the source of the data that it uses to create list items. Type the following code. This tells the list view that the model is composed of 100 numbers. We use an integer-based model for now because it will allow us to see how the list view behaves. The model could also be a QML list model, a JavaScript array, or a C++ model, amongst other things. The delegate is a component, a type of visual template that describes how list items will look. For our to-do list, we want a checkbox to mark items as done, and a text field to enter a description. We also want these items to be laid out side by side, so we'll add a row layout. Row layout comes from the QQuick layouts import and behaves similarly to the row from QQuick. Within the row layout, add a checkbox and a text field. These two types are controls from the QQuick controls 2 import. Run the application to see how it behaves so far. You might notice that the contents of the list view are visible outside of the frame, which is not what we want. We'll fix that shortly. The checkbox and text field can be interacted with, but as they are not hooked up to the model, any changes will be lost when they go far enough outside the list view. This is because list view destroys delegates that are not visible in order to save memory, allowing it to display large amounts of data in an efficient manner. To try this out, check the checkbox that is a few delegates down in the list view. Scroll down the list view by flicking or scrolling with the mouse wheel. Then scroll back up to the top. The checkbox is no longer checked as it was destroyed and recreated. Close the application and go back to Creator. Set clip to true on the list view. This will ensure that any list items outside of the view will not be visible. In the delegate, set width to parent.width. Now the row layout will be as wide as the list view, whereas before it was only as wide as the combined widths of its children, the checkbox and text field. We want the text field to be as wide as possible so that the user has plenty of space to write in. Add the following attach property binding to text field. An attached property provides a way to annotate an object with extra properties or signal handlers that are otherwise unavailable to it. In this case, we use the layout attach type to make sure that the text field takes up as much horizontal space as possible. Run the application to see the changes. Notice that the list view items are no longer visible outside of the view, and the text field is wider. Now we'll take a look at the model. Close the application and return to Creator. Replace the integer model with a list model. Within it, add a list element object with the following code. Each property in a list element is called a role. If you're familiar with C++ models in Qt, it's the same concept. The done role stores Boolean values, and the description role stores strings. Copy and paste the list element and set its properties to the following values. If we were to run the application now, we'd have two list items, but they won't display the data from our model because they're not connected to it yet. In the checkbox control, set the checked property to model.done. Roles from the model are available to delegates through the model object. We could also refer to the role directly without going through the model object. However, doing it this way will result in the code being easier for others to read and understand, as they can instantly see where the properties come from. In text field, set its text property to model.description. Now when we run the application, the checkbox and text field are displaying the data from the model. However, any changes to the control's values are not stored in the model. For that to happen, we need to respond to user interaction and set the values of the model roles accordingly. Close the application and return to Creator. In the checkbox, add the following code. Now whenever the checkbox is clicked via mouse, touch, or keyboard, the new value will be stored in the model. In text fields, add this code. This does something similar, with the only difference being that the editing finish signal is emitted whenever the enter key is pressed or the text field loses focus. Our to-do list can now be edited, but it's still using the QML-based list model. For some use cases, simple models like this are sufficient, especially if the data cannot be edited or does not need to be saved to disk in order to be persistent. In most cases, however, the logic of the application is in C++, and hence a C++ model is needed to provide its data to QML. Let's add a C++ model. Open the File menu and select New File or Project. Under the Files and Classes section, select Qt. Then, select Qt Item Model from the list. Click the Choose button. Now we're looking at a wizard that will create the skeleton of our model. For the class name, type To-Do Model. For the base class, select QAbstractListModel. This is a convenience class for implementing list models, and it's derived from QAbstractItemModel, which is the base class of all item models in Qt. Uncheck Customize Header Row, and check Items are editable. The header and source file names are automatically suggested for us based on the class name we entered. Click Next, and then Finish. We're now looking at todomodel.cpp. To start off, we're going to implement just enough functionality so that we can see our C++ model in our QQuick list view. The first thing that we need to do is define the role names that we were using in QML, done, and description. Switch to the header file by pressing F4, or right-clicking anywhere in the file and selecting Switch Header Source from the context menu. Add the following enum after the constructor. Add the following code after the last function. Right-click on the function signature and select Refactor, Add Definition in ToDoModel.cpp. We've now been taken to the definition of the function in the source file. Add the following code. In the row count function, add a return statement that simply returns 100. This will give us 100 rows in the model. In the data function, add this code after the fixme comment. Now the model will return placeholder data, but we still need to make QML aware of it and use it. Open main.cpp. Add an include for ToDoModel.h after the Qt includes. Then, after the line where QGUI application is constructed, add this code. This function registers our C++ model with a QML type system. Open todolist.qml. Add an import for our to-do library after the Qt imports. Replace the list model with to-do model. Open the build menu and select Run QMake. This ensures that mock, the meta object compiler, is run. Any class with a QObject macro that is added to a project requires QMake to be run. Now run the application, which will also cause it to be built. Our model data from C++ is displayed. Notice that it's not possible to change the values of the controls. To make the controls editable, we have to implement the setData function, which also requires us to store the to-do list's data somewhere. We could store the data in the model, but in a real-world scenario, the data is stored in the backend, separate from the model. Open the File menu and select New File or Project. Under the Files and Classes section, select C++, then C++ class. We're now looking at the C++ class wizard. Type to-do list into the class name field. In the base class combo box, select QObject. Click Next, and then click Finish. We're now looking at todolist.cpp. Switch to the header file. There are 3 actions the to-do list class should support in terms of to-do items: adding new items, modifying existing items, and removing items. Each to-do item has 2 properties that we defined as roles earlier: done and description. Let's make a to-do item struct to make it easier to manage multiple items. Add the following code above the to-do list class declaration. Include QVector after the QObject include. Add a private QVector of to-do items as a member variable of to-do list. Next, we're going to add 3 functions to support the actions we mentioned earlier. After the constructor, and before the signals keyword, add the following code. This will allow the model to modify the to-do list's data. Next, add 2 functions below the public slot section. These will be called by the QML code. Under the signal section, add the following code. Using pre and post signals matches up with what the model expects. It needs to be notified before something is about to happen to the data that it is exposing, and also afterwards. Now we need to provide a way for the model to access the data in the list. Add this function after the constructor. Let's implement these functions. For each function, except the signals, which don't need definitions, we're going to be using Creator's refactoring option to add a definition in the source file. Right-click on the signature of the items function and select Refactor, add definition in todolist.cpp. In the body of the function, add the following code. Do the same for setItemAt. In its body, add this code. First, we check if the index is valid, returning false if it's not. The setData function in ToDoModel returns a bool to indicate whether or not the data was successfully modified, so that's why we also return a bool. Next, add the following. This stores the current or old item in a local const variable. It then checks if the new item has identical values to the old one. If so, it returns false to indicate that nothing has changed. Finally, add this code. If the execution of the code has gotten this far, it means that the item has changed, so we store it in our list and return true. Now let's implement the two slots. Add a definition for append item via the refactor menu. Add the following code to its body. We emit the pre and post signals before and after appending the item. Eventually we will connect the model up to these signals. Go back to the header file and add a definition for remove completed items. Add the following for loop to its body. Then, within the for loop, add this code. We loop over each item in the list and check if it's done. If so, we emit the pre-signal, remove the item, and then emit the post-signal. If the item is not done, we move on to the next one. Finally, we're going to pretend that our list already had some data in it by appending a few items in the constructor. Our to-do list class is now done. Typically, C++ classes like this are created as part of a larger application backend in C++. So that's what we're going to do. We'll create an instance of the class in main.cpp. After the last Qt include, add this line. This is necessary in order to be able to expose the object to QML. Then, include todolist.h. After the QML register type call, add this line. And before the engine.load call, add this line. This is where the to-do list is actually exposed to QML. We set it as a context property, which means that it is available to any QML files loaded by the application. There are other ways to expose objects to QML as properties, but this is the most convenient one. Run qmake, and then build a project to check that there are no errors. Now we're going to make to-do model aware of to-do list. Open to-do-model.h and add a forward declaration for to-do list. We'll only be referring to to-do list through pointers in the header, so it's not necessary to include it yet. After the QObject macro, begin typing q_property, and then hit enter once the suggestion with the red icon on the left is visible. This is a convenient snippet that saves us some typing. Without changing the position of the cursor, type to-do list. Then, press tab and type list. The QObject attributes are automatically updated. Press enter to confirm the changes, and then add an asterisk to the left of the first instance of list to mark it as a pointer. Remove the notify list change part, as it's optional and not required in our case. Under the private section of to-do model, add this line. Right-click on that member variable and select Refactor, Create Getter and Setter member functions. Switch to the source file and add an include for todolist.h. In the constructor's initializer list, initialize mlist with a null pointer. At the top of setList, add the following code. Before the source of a model's data changes, we must call begin reset model. As we'll be connecting to the signals of the to-do lists, it's also a good idea to disconnect from the old list when setting a new one. In our case, this isn't necessary, as the property will only be set once. However, it's a good habit to get into. After the list has been assigned, add the following if statement. If a valid to-do list was set on the model, we will connect to its various signals in order to call the begin and end functions. Add the following code within the if statement. This connects a lambda to the pre-item appended signal of to-do list. The lambda calls begin insert rows with an invalid model index, which is fine as we want to add the items to the root node of the model. The next two arguments are the first and last indices within which the new items will be inserted. Since we want to append items to the end of the model, we use an index that is one past the last valid index in the list. Next, connect post item appended to a lambda that calls end insert rows. Connect pre-item removed to a lambda that calls begin remove rows. Finally, connect post item removed to a lambda that calls end remove rows. To match the begin reset model, we also call end reset model. Now is a good time to build a project to check that it compiles. We're almost ready to use our model in QML. Let's implement the remaining functions. In row count, add a null pointer check to the if statement. We're going to do the same for other functions that use the mlist member variable, as it's a good practice to safeguard against null pointer accesses. Remove the fixme comment and change the return statement to return the amount of items in the to-do list. In data, add the same null pointer check. Remove the fixme comment and store the current item in a local const variable. In the switch cases, return the relevant data for each role. In set data, add an if statement that returns false if the null pointer check fails. Then, store the current item at the index in a local variable. We're going to check which role was set and update it. Copy the switch code from the data function and paste it after the last line we added. Modify the done role case so that it looks like this. Then, modify the description role case. Remove the fix me comment and change the if statement. We take advantage of setItemAt's return value to determine whether or not the data has actually changed, and therefore only emit the data change signal if we need to. Finally, if the data has changed, we return true, otherwise false. In the flags function, remove the fix me comment. The item is editable flag is enough for our use case. Open main.cpp and add the following code after the call to QML register type. This registers to-do list as a QML type so that it can be used as a property of to-do model. As it is a backend type, we don't intend for it to be created in QML, so we use the QML register uncreatable type function. This function prints the error message that we passed as the last argument if we attempt to instantiate the type in QML. In todolist.qml, assign the to-do list context property to the list property of to-do model. Run the application. We can now edit the model data that comes from C++ in our QQuick list view. Before we can consider our application complete, we need to make it possible for users to add and remove items from a list. We're going to add two buttons below the to-do list to achieve this. Close the application and add a column layout as a parent of the frame. To quickly re-indent a QML file, select the code and press Ctrl-I. After the frame, add a row layout. Within the row layout, add 2 buttons. Run the application to see how it looks so far. Notice how the buttons happen to align nicely with the width of the list view. While convenient, this is just a coincidence. We need to take a few steps to ensure that the combined widths of the buttons match the width of the list view, and vice versa. To simulate how wide the buttons might be on a system with a larger default font size, let's temporarily add some text to the labels. Add 3 spaces at the end of each button's text string. Next, we want to make sure that each button fills the width of the row layout. Then, add the same binding to the frame. Finally, make list view fill the frame. Run the application again. Now, if the button text is too wide, the list view will stretch accordingly. Remove the extra spaces from the text. To complete our application, we need to make the buttons do something. Add the following to the Add button. Add the following to the Remove button. Run the application again. We can now add, edit, and remove items from our C++ model